Hello and welcome to Beginners Python and Machine Learning. My name's Tim Cummings. Tonight we're doing it's going to be like a 1.5 hour session, but only the first half hour will be streamed. And I'm going to, so I'm going to run through it pretty quickly, and then the next hour is going to be an in-person session. So if you've got any questions, you can ask any questions during the stream, either on the YouTube chat or, so I'll be following YouTube chat here, and I'll put that on live chat so it's all messages. And also on our Slack channel in Learning to Code. When the stream finishes in half an hour, you won't be able to use YouTube chat anymore, but you can continue to ask questions on Learning to Code because we'll have a few people here and they'll be asking questions. We'll be going through it all a bit more slowly. So apologies for going through it quickly for the streamers, but you can always pause the video and try to catch up. All right. So tonight what we're going to do is we're using message queues to send messages between different Python programs. We're going to have one Python program running on your computer and another one running on a Raspberry Pi. And the Raspberry Pi is going to is wired up to turn LEDs on and off. And I've even got a Raspberry Pi set up here, and there's our Raspberry Pi. So we'll see if we can, from the comfort of our home, turn the LEDs on and off on that Raspberry Pi. Okay, so at the Meetup and on the webpage and also on the YouTube video, there should be a link to our GitHub repository, and that's where you'll find this Meetup 167, Internet of Things. So if we go to that link, this will give us the source code. So I've got all the source code here, and what's probably the best thing to do is save that to your computer. So if you click on the raw button, you'll see just the raw source code, and then you can save that file. More tools, save page as. It'll save it like it is, but let's put it somewhere useful. So in Documents, I'll create a new folder for tonight's session. We'll call it Beginners Python Machine Learning 167. In that folder. So I'm running on a Mac, but this should work on Windows as well, and even Linux if you're putting it. Okay. Now you can do this from the command line, but I find it a bit easier to use an IDE, so I'll be using Pycharm. By the way, just let me know if the volume's okay and the audio is working. It's the first time I've got a video, so I'm trying a camera to play. All right, so let's create a new project in Pycharm. In fact, why don't I'll go back and why don't I just open a project and then open that folder I've just created. And that'll be our project folder. So while it's starting up, here we go. Click on Open, and in Documents, there's our project folder. Trust the project. Okay, now you know I always like using a virtual environment in these projects, so the first thing we need to do is set up a virtual environment. And Pycharm makes that reasonably easy. We can also do it from the command line. Let's see what Pycharm, if it's worked out how to do a virtual environment for us. So I go to the project here, and I'll say which project interpreter, Python interpreter will be being used. And see, it's currently just going user local bin Python. So that's just your system install that I've got here of Python. So we want to create a new one. So let's create one. And we can just put it in the VMV directory, in our project directory, that'll work. And I've chosen virtual environment here, virtual environment. If you're using Anaconda, then choose Anaconda environment. And don't bother with these other ones unless you're using Poetry. I haven't used Poetry myself, but I thought it was quite good. So the virtual environment means that we can install third-party libraries and they won't affect our other projects that are on the same computer. So the third-party libraries that we want to install are these ones here, PAHO MQTT, so this is the message queue library that we're going to use. And because I had to draw some circuits for the Raspberry Pi, I actually installed this one here, SchemDraw, which turned out to be quite fun. So let's, and the way we can do that, we create a requirements.txt file. So I'll just right-click on our project folder up here, and we'll say new file. And by convention, it's useful to call it requirements.txt, but you can call it anything you like. And we want to put those two third-party libraries in there. So I'll copy and paste them out of there and put them into here. Now Pycharm's asking me to whether I want an extension for requirements.txt. I don't need that. But do I want to install those requirements? And yes, I do. So I'll click on install requirements. Okay. So it hasn't worked out yet that it wants to use that new virtual environment that we've got. Yes, we need to select it. I've now selected the new one we've created. And that way we can install things without requiring administrator permissions as well. Okay. All right, I'll try to talk up a bit. Okay, we've installed the requirements. Packages to install, yes. And that goes off to the Python libraries and pulls down those packages and any dependencies that they might have. So while they're installing, let's have a look at what we're doing here. So the first thing you need to do is run a message queue broker. And I've already got one of those running on my a server at home. And I've opened up the firewall, so this will be running for this session. But after the session, I'll be turning it off. So you'll need to run your own if you want to keep working on this after the session. If you use Docker, there's some commands on how to get it running in Docker, or you can find a public MQTT broker that you can use. So, yep, so mine's up and running, and let's have a look at the code. So we're going to be using this third-party library, and we're going to call up the client module, and we're going to just call that MQTT for brevity. Now the first thing I want to do is show you the circuit for how to wire up your Raspberry Pi if you want to do it on your own Raspberry Pi. And so I've used the scheme draw technique to run this function here, draw schematic. So we can say draw the schematic and we want to show it, and I'll just put the program when it gets to here. And now we can run this. So we can run this from the command line. So if you wanted to run it from the command line, you go to your terminal, and you can see in the terminal we're in our virtual environment, because it's got the only virtual environment at the beginning there. And then we can type Python, Meetup 167, and that will run. And there we go. The first thing it does is it creates an SVG file with our circuitry of how we've set up the Raspberry Pi. And you can see I've used the GPIO ports. 3 of them I've got connected to LEDs, a red, blue and a green. And another 2, 17 and 27, I've linked to 2 buttons, the left button and the right button. And then we've got, the whole thing runs on 3.3 volts and ground. So that's about as much detail as I'm going to go into on how to wire up your Raspberry Pi. But you'll see here's the that circuit file that we've just created is now been created in our folder, and so you can refer back to it at any stage. Even in Pycharm knows how to render an SVG file. So it's pretty cool. Okay, now the next time I want to run this, I don't want to show the schematic anymore. I don't want to quit when I get to it. So we're going to create a function called now, which really just takes the current time and formats it nicely. So that's going to be useful to so we can see how things are working. These are your connection parameters that you're going to need to use our MQTT server, which is like a messaging server. So it's just on port 1883. That's the domain name that you'll have to change if you want to use your own one. We've created a topic called BPAML, and we've created a few other topics as well if you want to get more advanced into it. So to use MQTT, you create a client by calling this method here. It creates an object of that class, and then you connect to the broker URL. And then you have to specify what quality of service you want. So we're specifying here 0, which means it's not guaranteed to get through, but that's the lowest overhead when you're using MQTT. So you could also choose 1 or 2. 1, you might get duplicates. 2 is guaranteed to get through, and with exactly 1 time per message, but there's the highest overhead in that, so you just choose compromise for your situation. And this field here, retain, only show the messages to those subscribers currently connected, and if it's false and if it's true, then those messages will stay on the server so people can connect later and still catch them. All right. So here we're just going to do a connect and a disconnect. And I think I've turned logging on back up here. And we've got debug level logging. So let's just do a connect and a disconnect and see what happens. And then our code will stop here when it gets to here. So I'm going to run that. So last time I ran from the terminal. This time I'm going to run. So on a Mac it's Control-Shift-R, and on Windows and Linux it's Control-Shift-F10 for the current file. And that just ran and quit. And didn't do any logging like that. So let's just put a logger command in here just to make sure that we've got to this line. Just going to give it a blind one. Yeah, so I got through there and it finished. All right, now I've got a Raspberry Pi running, so I'm just going to connect to that. So I've got two networks running here. I've got the Wi-Fi that I'm streaming over, and I've got an Ethernet cable that's connected to the Raspberry Pi. So, okay, so there's my Raspberry Pi. And the Raspberry Pi has, I've created a virtual environment. And so to instantiate that, activate that virtual environment from the command line, you use the source command if you're doing Windows or Linux, and if you're on Mac or Linux, and if you're on Windows, then you run the scripts. So the scripts will be in the VENS, MQTT. Well, in fact, this is the Raspberry Pi, so it's always going to be Linux. And then activate. So you have to run source and then activate in the bin folder of your virtual environment, which I've called MQTT here. All right, the virtual environment is active. Now I've got some code, and I've downloaded all the session summaries from our GitHub, and in the online folder we've got one, Meetup 167, and there's two in there, but the one that we want to run on the Raspberry Pi is called Internet of Things RPi. So if I run that well, I'll just see it's testing my LEDs. It's saying press and hold the left button until the blue LED flashes, and then press and hold the right button until the red LED. Okay, that's good. And so we're back. So our little self-test worked on our code, and we're also getting any messages that are going to our message server. So let's leave this window over on one side, and we'll go to Pycharm on the other side. And we'll run our Pycharm code. So there we go. Our Raspberry Pi picked up the message that we sent, which was called Tim's Challenge 1 message, and we used our now function to format the code into hours, minutes, seconds, and fractions of a second, microseconds. Okay, so it's all working pretty well. Let's continue on. Challenge 2, subscribe to other people's messages by setting callback functions. Okay. So when we subscribe to other people's messages, we want to set up some actions that are going to happen when it receives messages over the MQTT broker. We want to say what's going to happen when we connect, when we disconnect, and when we message. So I've just created 3 functions here. They can be called whatever you like, but it needs to have these parameters in it, what the client is, what the user data has come with it, with the message, and the flags and RC. That's the result code. Yep. So let's create a second client, this one for challenge 2, and then we set this attribute of the second client is what the onConnect function is going to be, and we're going to refer to it as onConnect. That's a really clever thing you can do in Python, is you can just refer to a function by its name, and it's a first-class object. So it's just like a variable with a name, but what the variable is containing is this function that we've defined up here. So if you put parentheses after that name, it will call the function and return the result of that function. But we don't want to call it at this stage. We just want to link it to client 2. So we do that by using the name of the function without parentheses. So we set up those 3 actions, the callback functions, and now we'll connect to the broker URL and subscribe to our topic, which is the BPAML topic. And we'll also put in a message, and then we'll wait for 5 seconds to see if any messages happen. Now, while we're waiting for things to happen, if we start this loop start, then it will create a new thread where the actions take place. But we have to release our thread that we're in the program so that it can run the other actions. And so you use the sleep command, say you can leave this thread for 1 second and go off and do any others that may have come up in this time. After 5 seconds, we're just going to stop the other thread and disconnect. So quit when it gets to there, and then we'll try running it. Okay, so we published our results. I could probably it responded to the got disconnected. I'll try running again and see if I can generate a message from the Raspberry Pi. That's all right. I'm just going to go through this quickly, and you can play around with setting your own messages, maybe setting up this program to run twice on the same computer, and see if you can send messages backwards and forwards between the two. All right. So let's go on to challenge 3. Subscribe to more than one topic, and we have different callback functions based on which topic it is. So once again, I'm not going to go into too much detail because I'm running out of time. We've got a few minutes left of this session. Now, when you're setting up your client, you can set up a client ID as a unique number, and that way it'll help you with your sessions. If you come back to it later and you say clean session equals false, then you can pick up all the things that you've missed while your program hasn't been running. So I'll show you how you do that. You just copy this bit of code here and put that into your Python console. There's a Python console, so I just paste it in there, and it's come up with a unique ID. So I'm going to use this one, but you should run it yourself and get your own unique ID. And then we can run this bit of code. And here I can just press the play button, which is another way of running it in Pycharm. So then it does the challenge 1, challenge 2, and we've got the several messages and our callback functions. All right, that's all I'm going to do for that one. Now, challenge 4, we want to send messages to the Raspberry Pi that are going to turn on LEDs and send more messages. So it's just examples of more messages. So I'm going to put some logging statements in here just to make it a bit easier to see what's going on. So this is client 4. And we'll do the same thing for the LEDs. All right, I'll save that. We've turned off the quit. Yep. So client forward will start. All right, so let's run this. And I'll have a look at our Raspberry Pi for 5 seconds, and now we've got the lights flashing as our code's running through. So that bit of code was running on my computer here. It sent a message to my message server. I'm at Brisbane Business Hub. It sent a message to my message server, which is in my house. And then the Raspberry Pi, which is also in the Brisbane Business Hub, was connected to that message server, and so it picked up those messages, and that got the signal to turn the LEDs on, and you saw them flash one at a time, and for so many seconds, and 1 second each, and then finish. So it's pretty simple code, but we've been sending messages all around the world, controlling remote devices. And the Internet of Things is really using these messaging protocols to control small computers like the Raspberry Pi, or even smaller wearable computers to do things. All right, so that's all for the streaming session tonight. I hope you've enjoyed it. I hope you've learned something, and I hope you can get one of these things up and running, because it's certainly a lot of fun setting up the streaming. Setting up the Raspberry Pi and the wiring to control things, and you can do more advanced things than just turning LEDs on and off. So next week will be an absolute beginners session. It'll probably just be an online session next week. We have to book this Brisbane Business Hub a fair bit of time in advance, so we'll see how that goes. And then after that, hopefully we'll give you a machine learning session. Okay. Thank you very much. I'll see you later.